Okay. All right. Well, we'll take a look at today's material. Give me a second here. So we are looking at subsetting. So I didn't say this about Wednesday's lecture, but there's related reading from the Advanced R textbook as well. So you can. So the textbook is available to read for free online in your browser. And today's stuff comes from Chapter 4. Wednesday's stuff is mostly from Chapter 3, a little bit. Actually, I would say Wednesday's stuff comes from more from the first edition on data structures. Okay, first edition, but Hadley Wickham updated for the second edition. But anyway, today's lecture comes largely from Chapter 4 in the textbook. Okay, this is a great textbook, and I hope you don't mind having to read it in the browser. Of course, if you want the paper version, you can spend money and buy a paper version of it. But I feel like most students are okay with electronic reading, if not even prefer electronic reading over paper versions, right? Depending on like the age of people you talk to, somebody will be like, oh, I love having I love feeling the texture of paper in my hands, and I get it, but I think I like digital versions a little bit more these days. Okay, anyway, let's talk about subsetting different data structures. So we have, vectors, we have matrices, we have lists, we have data frames. How do we subset those things? And subsetting is really the idea of, you have the entire data structure, which has, maybe it could have hundreds or even thousands or even more data points in it, different values, and perhaps you only want to work with a subset of them. You only want to work with some of them. You only want to work with the values that correspond to people from California. You only want to work with values that correspond to people over the age of 65 or something like that, okay? So we'll just look at some basic ideas, and all of these can kind of generalize to larger data sets. So first we're going to talk about subsetting an atomic vector. I imagine a lot of this is familiar already, but just the example vector that we are working with will be this simple numeric vector, type double, okay? And it's the values x, and the values are 2.1, 4.2, 3.3, and 5.4. They are not sorted from least to greatest, but the values after the decimal point, the 0.1, 0.2, 0.3, 0.4, have been chosen so that you can see where they originally were in the original data set, okay? And so we'll subset. So we've got a few different methods for subsetting. Probably the first and most familiar method for you is subsetting with positive integers. And again, here's our original vector. And you can put in single square brackets. You can put in a little vector of positive integers. And so you could say, I want to subset x and select the third and first values, and it selects the third and first values, okay? And that's how you do that, right? And so you can put in any kind of range of values. You could put in 100 through colon 110, and you'll get the 100th through 110th values in there. Order is a function that you can apply to a vector, and what order will do is it will select the indices so that if you were to subset the vector using order, it will place them in order from least to greatest. So when you sort x, you would get this, and this is the same thing as selecting the first value, then the third value, then the second value, then the fourth value, and that will put this into order. So that's what order does. It doesn't give you the sorted vector, but it gives you the indices needed to put the vector in order. If you subset using duplicate indices, so here I said subset X using index 1, comma, index 1, it will repeat the value 2.1 as many times as it appears. Okay, so that's no problem. If you give it a vector with decimal values, okay, they are just truncated silently. They are not rounded. They're just truncated. So if you subset using 2.1, it's going to just select the second value. If you subset using 2.9, it's going to select the second value. So I would say not recommended. Generally, you want to put in integer values. But sometimes you might do some kind of mathematical computation. Okay, and when you do this mathematical computation, you decide, I'm going to subset using that. Now, we will learn later on a number that appears like 3 could actually be 2.99999, okay? And even though on the computer it displays as 3, maybe internally it's stored as 2.99999, and it might subset to the wrong value. These are just kind of things that happen when you're dealing with floating point numbers. It could happen, so just something to be aware of. Negative integers will omit those values. So if I say subset X using negative of the vector 3, comma 1, okay, basically it says get rid of vector item 3, get rid of item 1, and it will just give you the values that remain in the order that they originally appear. So we drop the first element, the third element, we're going to get 4.2 and 5.4. Now you can't mix negative and positive elements because this is just confusing. We're saying we don't want the first element, we do want the second element, and now R is confused. Well, what do you want me to do about the third and the fourth? Do you want the third and fourth elements? Do you not want them? It's ambiguous, so it says you can only zeros may be mixed with negative subscripts. It gives you an error specifically telling you what went wrong. Perhaps one of the most useful methods of subsetting as well is subsetting using a logical vector. Okay, so logical vectors being values like true or false, and when you subset using a logical vector, basically anything it matches up the elements and it recycles if necessary, and any values that match the true will be returned. Any values that match false will not be returned. So here is a vector of length 4 that corresponds to the 4 elements here, and so it's going to return 2.1 and 4.2, and it won't return 3.3 and 5.4. So when you subset using that logical vector you have there. Here is a logical comparison. We say x greater than 3. X greater than 3 by itself will return a logical vector of trues and falses. So it will return false for 2.1 because 2.1 is not greater than 3. But 4.2 is greater than 3, 3.3 is greater than 3, and 5.4 is greater than 3. Those values get true, and so the values that where this statement is true, where x is greater than 3, get returned, and so we get basically everything but 2.1. But this can obviously be kind of expanded and generalized to any other kind of logical comparison. So you can say, is it equals 2.1, and it will return the values that do equal 2.1. You can also use a different column or another vector of the same length and have some kind of logical statement of comparison there, and it will give you back the corresponding values. I think this is familiar, and so I'm kind of going through this quickly, and I hope that's okay, but you need me to slow down, I'll slow down. If you have a logical vector that's shorter than the one being subset, it will be recycled, all right? And so this is what we have here. So here I have true, false, just 2 elements, and it gets recycled to basically be true, false, and so it returns the first and the third elements. If you have a missing element or an NA, then corresponding when it gets subset, the corresponding values will come back as NA. So I have true, NA, false, and it's going to give me 2.1, 4.2 NA, and not the fourth value. And if I have true comma NA, then that gets recycled, true NA, and we're going to get 2.1 and 3.3 in NAs, where the NAs are there. If you put nothing in these inside the square brackets, then that will return the original vector. As far as simple one-dimensional vectors, it's not particularly useful. You'd probably just use x by itself. But it is very useful for kind of two-dimensional structures. So if you want to just get the entire row, you'll leave nothing in for the position before the comma. I mean, all the rows, you get nothing, put nothing before the position before the comma. Or if you want the entire row, all the columns, you'd put in nothing for the position after the comma, things like that. Okay. It's also useful if you needed to do assignment with subsetting as well. If you put in a 0 inside the square brackets, you will get a 0 length vector. This is often not something you do on purpose, but perhaps if you're trying to work with test data. So, how does my function work if a zero length vector gets input, right? Is that going to crash my function, or is it still going to be able to function? And so using a 0 length vector can be handy there. All right, let me go ahead and give you your first view quiz answer for week 1 Friday. Week 1 Friday, your first answer is the letter B. B as in bear. I cannot select these. Okay, so B. B is your first view quiz answer, so jot that down. First view quiz answer, B. Sometimes you have vectors and the vectors are named. Okay, so here I have that vector 2.1, 4.2, 3.3, and 5.4, and I use this function set names, and we're going to use ABCD to set the first, use the first 4 letters of the alphabet and set those as the names. And so here you can just subset using the names, D, C, and A, and it's going to pull the corresponding values, D corresponding to D, C, and A. Okay, I'm not sure what's going on. What's this? And so when you see a vector, the values are these numeric values, 5.4, 3.3, and 2.1. Those are the values of the vector, and the D, C, and A are just names of the elements in that vector. Okay, like integer indices, if you repeat the name, that element will get repeated. If you have a name that's like ABC or DEF or something, the names have to be an exact match. So here, if I do select A and the name is ABC, it's going to pull back an A. It's going to say I couldn't find this name. So a useful application of named vectors is you can create like a lookup table. So here I have this vector X, and I have the letters M, F, U, F, F, M, M. Okay, it's a character vector. And let's say I wanted to replace all instances of M with male, all instances of F with female, all instances of U with missing. Okay. Well, I create a vector called lookup, and there's only 3 elements in this vector. It's a named vector with 3 elements, male, female, NA. The name corresponding to male is M, the name corresponding to female is F, the name corresponding with NA is U. And now I'm going to subset this lookup vector, which has 3 elements, using the vector X. Okay? And because we can, have repeated indices and whatnot, okay, it's going to look up the name, look up the value corresponding with the name M, the value corresponding with the name F, so on and so forth. And so now we get the entire vector kind of with everything replaced as we want it replaced, right? So we get male, female, NA, female, female, male, male, et cetera, et cetera. And then if you want to drop the names that appear here, then you can unname the corresponding vector as well. And so now we've gone through and we've basically replaced all instances of M with male, all instances of F with female, and so on and so forth. So this is kind of a useful little thing if you find yourself in a situation where you need to kind of replace, certain values with other values. Okay, let's talk about lists. So lists are an important data structure. Data frames are lists, but we can also, we treat them like vectors, but we allow them to contain values of different type. And so subsetting list works very similar to subsetting an atomic vector, but there are two kind of different subsetting operations that you can do. One uses the single square bracket and another uses the double square bracket. When you subset a list using a single square bracket, it will always return a list. If you subset a list using a double square bracket, it will pull out components in the list. One way to think about this, okay, is you can think of a list as a train, right? And so you could think of a list as a train, and inside each kind of box of the train, you have, different objects within each kind of train car, right? So if you have x double square bracket 5, that is going to extract the object that is inside the car, okay? Whereas single square bracket 4:6 will pull out cars 4, 5, and 6, right? So if you think about a train and each kind of car can contain objects in it, that's a little bit like a list, okay? You have kind of list elements. The list elements are like train cars. Inside each list element, you can have another object in there. So here's kind of the illustration. Here we create a list X, and there are 3 cars in this list. We have the first train car has the vector 1, 2, 3. The second train car has the letter A. The third train car has the vector 4, 5, 6. So when you subset using single square brackets, it will always return a list. It will always return basically a train car, the first train car. It will return the train car that contains 1, 2, 3. If you use the double square bracket, it pulls out the element inside the train car. It pulls out the vector itself, 1, 2, 3, not the train car. Okay. So a couple more examples. These are all using single square brackets. So anytime you use single square brackets, you're going to get back a train. So here's the original train X. Single square brackets 1, 2 will give us the first 2 train cars. -2 will give me the train without the second train car. 1, 1 will give me the first train car duplicated, okay? And then 0 will give me a list, okay? It's a train, but no cars, right? So it's a length 0 train. Just a little bit more. So here I have, now I've named the elements of my list, okay? So here X is a list. The first element is named A, and it is contains the vector 1, 2, 3. The second element, the second train car, is named B, and it contains the letter A. And the third train car is named C, and it contains the vector 4, 5, 6. And so you can ask for double square bracket 1, and that will pull out the element, okay, the vector 1, 2, 3. You can also use double square bracket with the name A, and it will pull out the same vector 1, 2, 3. So again, with the double square brackets, it's pulling out the element inside the list, and in this case, it's that vector 1, 2, 3. Whereas if I use single square brackets, what we're going to get back is a list. And so again, here I'm saying give me back a list or a train with cars A, B, and B, and so I get back a new list or a new train with those cars, okay? Whereas if I try to use double square brackets all right, A comma B, this is not going to work, all right? You cannot, when you use double square brackets, you're saying give me the object that's inside the car. And so you can only specify one car at a time when you're saying give me the object inside the car. You can't say, hey, give me the object inside the first car and combine it with the object inside the second car, right? If you wanted to do that, you have to explicitly do that, because what's inside the first car could be numbers and what's inside the second car could be character, and so it doesn't automatically combine. So if you wanted to do something like that, you'd have to say, you'd have to explicitly say combine elements inside the first car, right? So you do double square bracket 1, comma, double square bracket 2, and then because you're combining that, then R will say, okay, now I need to do some coercion so everything becomes the same data type and things like that. So you can't just say double square brackets and give it multiple things, okay? Now, technically this is not, it's resulted in an error here, okay? But the error it's a little bit weird. It says subscript out of bounds. And technically this statement, okay, double square bracket A comma B is actually equivalent to this statement, X double square bracket A, then double square bracket B, okay, which this will actually work if you have a list with an element A, and within element A is a list with an element B, okay? So it is technically not illegal. It's not illegal. It's not like you're going to get arrested, but this command could work and not result in an error if you have like a list and within that list you have this thing. And so here I have X, which is a list with two elements, A and B. A is a list, and B is this vector 1, 2, 3. And then within A, is a list with the named elements A, which is A, and B, which is B. And so double square bracket A references this first list, and double square bracket B references the second element in that, and it gives me back the letter B. And then these two things are equivalent, and they both give me back this thing B. I intentionally wrote not recommended just because I would say don't make a habit out of using this. And I only kind of put this in here just for kind of completion and clarity, just because you might encounter somebody who used this in their code and you're like, oh, I thought that was not allowed, and why is this showing up? And, but basically, don't do this, all right, is my recommendation. But sometimes as you're reading other people's code, they do things that I personally would not recommend, but it works, and now you have to understand what's going on there. All right, let's do a couple more examples here. Here is a list D. Inside the list D, I have three named elements, A, B, and C. A is a vector 1, 2, 3. B is a logical vector, true, true, false. C is a character vector A. And here's this function I didn't explicitly mention, but it's str. str gives you the structure of whatever data object it is that we're looking at. And so here, when you say structure on D, it explicitly lists it out, and it says it's a list of length 3. Here are your elements, A, B, and C. A is numeric, B is logical, C is character. That's what we have. Okay, so here I have D single square bracket 1. This gives me back a list of length 1 containing the vector 1, 2, 3. Okay, and if I say what is the type of D single square bracket, we're going to get back a list. Okay, and so this difference between single square bracket and double square bracket, and do I use list and things like that, this is one of the, I would say, most common sources of frustration with students and just kind of like working with lists and vectors and stuff in R is if you get these two mixed up, or if you can't keep them straight, it's going to be frustrating working with things. And so, one of your tasks in this first homework assignment is to it's like extract the elements and sort them into these are numeric and whatever integers and stuff like that, and you have to be able to work with lists, and this is intentionally some kind of thing where you're like, I'm forcing you to work with lists and help think through it, okay, as far as, okay, in this case, do I need to use a single square bracket or a double square bracket and stuff like that. And so anyway, single square bracket always returns a list, whereas if you want that vector, you use the double square bracket, okay? Double square bracket 1 gives you that vector 1, 2, 3, and you say, what's the type of this? And it says, oh yeah, this is a type double vector, okay? All right, here's another list. This one is not named, and we've got integers 1 through 8, the characters 1 through A, B, C, D, and integers 5, 4, 3, 2, 1. And so this is a list, and again, here we no longer have names. So how do I refer to the elements in here? Okay, so single square bracket, again, this is a list, and the way I know when our outputs that this is a list, because it's preceded by this double square bracket. This double square bracket 1 basically says the element inside that first train car, the element inside the first element of the list, is this numeric vector 1 through 8. Okay. Whereas here, if I do L1 double square bracket 1, it's not preceded by this, so it's indicating, yeah, this thing is not a list. It's just that vector 1 through 8. Okay. So far, so good. Okay. What is happening here? So here, all right. So if I do L1, single square bracket 1, single square bracket 2, I get back null. What's happening here? Okay. What happened here, okay, is that when I did L1, single square bracket 1, it's giving me back a list, a train, and it's just that first element, okay? So it's giving me back this thing, okay? And then I say, hey, what is the second element of this? What's the second element of this train? It doesn't exist, right? Because it's saying, hey, what's the second car in this train? There's no second car in the train, right? Because that's what the single square bracket thing is saying. It's saying, hey, what's the first car in the train? And then once you have that subset, right? So now think of this L1 single square bracket 1 as like a new element. And from here, we're saying, hey, what's the second element in this train? There's no second element in the train, so we get back null. A list containing a null list, okay? Whereas over here, we're saying, okay, what is the object inside the first train, okay? The object inside here is this vector, 1 through 8, and then we're saying, hey, what's the second element of that, right? So think of this as kind of like L1 double square bracket 1 as it's like its own thing, and once you have that, what's the second thing in there? That's the number 2, okay? And again, this is the recursive subsetting, which is equivalent to doing L1 double square bracket 1, then double square bracket 2. And so you could subset an atomic vector using double square brackets, and it'll just give you the second element. Again, the recursive subsetting is not quite recommended, but that's what you'll get. Okay, so here I have another thing where I've got a list inside of a list, or a train inside of a train car. And so here, the first thing is the top level train is we have 3 elements, okay? And the first train contains this list L1, okay? So I've got a little train inside that first train car, then I got a second train car containing 10, 20, 30, and then I got a third train car containing D, E, F, G. So what is this? When I do single square bracket L1, what is, and if I say what is the length of L2 single square bracket 1, what is its length? Is it 1 or is it 3? It's length 1. This is the top level train with just one car in it, okay? But inside that car is another train, okay? But we say, hey, what is the length of this train? And it's just length 1, right? So it's length 1, but inside there is a train with 3 things. And so that's shown by double square bracket 1, and then it's showing you, okay, and this, a lot of times this kind of notation throws people off, but once you understand how lists in R work and how it gets printed out, then this will make sense. So this is saying, okay, it's length 1 list, or the first element in the list, double square bracket 1 is up here. And then within that, we have a list. And so within that first train car, double square bracket 1, double square bracket 1 there, the first element inside that first element is this vector. Second element within that first train is this, and the third element within that is this. Okay, so if I say, what is the structure of L2 single square bracket 1? It says it is a list of 1. Within that list of 1 is a list of 3. And that's what we're saying. Okay, let me give you your second view quiz answer. Second view quiz answer today is the letter D. D as in dog. D as in dog is your second view quiz answer. D. Okay. All right, now if I do L2 double square bracket 1, this returns not that first train car containing the train, but it returns the little miniature train inside that first train car. Okay, so when I say L2 double square bracket 1, it's returning the little train of 3, the little miniature train inside there, and that's going to be a list of 3. So L2 double square bracket 1 gives me back that list of 3, and when we say L2 structure L2 double square bracket 1, we get the list of 3. Okay, so I want to make sure you guys understand the difference between this and this, and if you can keep these things separated and know the difference, then that will be helpful. Okay. All right, this is like a little I guess a little puzzle game or something. Okay, so double square bracket 1. First thing, what is this? This is giving you back the first car in that little miniature train. Okay, so it's a list. Whoops. This is asking, okay, if we've taken out the train with the first car inside there, and I ask, what's the second element? Well, there's nothing there, so we get back a null. This gives me, this is saying, hey, what is the element inside the first train car of the little mini train inside the bigger train? And that is a vector. And here, if I say, hey, what's the second element of that? That's the number 2. See if you can explain this to an imaginary friend, and that will help you understand, right? Some of you had Professor Tang, and did you get like a little rubber duck? Okay, so when you come to study, okay, so rubber ducks are great in terms of like, and if you didn't have Professor Tang and you didn't get a rubber duck, that's okay, all right? You can just talk to your water bottle, right? And you just pretend this is a friend and you're trying to explain things. And so as you're studying, you can say, all right, let me try to explain this thing to you. And then as you try to explain through some of the slides, then hopefully that helps you understand things, right? There's I don't know if you've ever had the experience of like tutoring another student or something, and it could be like a subject that you're familiar with, but when you have to tutor someone, you realize, oh, you know what? I'm like learning a lot when I'm like trying to teach someone else something, right? And so a lot of times when it comes to studying and you say, well, how do I study, right? Like, I don't know how to study. One thing is you just pretend you had to teach somebody, right? And even if it's like teaching your water bottle, it's helpful. Just kind of, it feels embarrassing, but I'm always talking to myself anyway. So, but I've lost my sense of shame a long time ago. So, all right. Let's see, double square brackets on atomic vectors, you can do this, right? So you can take some vector, you can use single square brackets. This is how we normally subset an atomic vector, but you can use double square brackets. And one difference that it does is if the vector is named, it drops the name. One thing, another difference though, is that when you use single square brackets for an atomic vector and you give it an index that doesn't exist, it's going to return NA. So if you say, hey, what's the fifth element of this vector 1, 2, 3, it's going to say that's a missing value. Whereas if you use double square brackets and say extract the fifth element, so that's one way you can think of it, as double square bracket is like extract out, and you say extract out the fifth element from this vector, then you're going to get an error, okay? And you're going to get subscript out of bounds. And so sometimes when you're writing a function and you want to make sure you're going to get the thing that you're looking for. Sometimes you want to actually use the double square bracket so that it returns an error if you're ever trying, like if the person ever requests for something that doesn't exist, right? Because maybe you get the NA, maybe, right? So this is going to return an error and says subscript out of bounds, okay? If you try to subscript using null, you get a length 0 vector, double square bracket with null, it's going to give you back an error. So these are just, this is one of the difference between single and double square brackets on atomic vectors, okay? Let's look at what happens when we do single and double square brackets and the OOB is out of bounds index, okay? So this is another error that you encounter is you'll get something out of bounds index, and basically out of bounds means your list is length 3 and you're asking for the 4th thing, or you're asking for the 5th thing. So it's out of the boundaries of the currently existing object is what OOB, out of bounds, means. And null is basically you're giving it something length 0. So sometimes you do some kind of computation, right? And you say, hey, give me the vector of everything where it's people from California, all right? So, and then, but in your data set, you have no one from California, okay? So then the result of that is what? It's null, okay? And then sometimes, and then you say, okay, now using that, pick out everybody from this thing, right? So what's gonna happen when you do that kind of operation, right? Because you're like, well, when am I ever gonna do OOB, or when am I gonna ever do null, okay? It's not like you intentionally do this from the start, but a lot of times you're gonna say, hey, look at this thing, find everybody that meets this criteria, and then using those results, pick out the corresponding matches, okay? And a lot of times you might have some kind of a set of criteria that doesn't return anybody. Then what's it gonna do, right? And if you understand when this is gonna return an error or when it's gonna return something that's length 0, that's gonna help you avoid and troubleshoot some of your issues. So if you give it an out of bounds index and you use single square brackets, you're gonna get back a train with null, okay? So that's basically your empty train with no cars. Here we have, if you do double square brackets for with 4, you're gonna get subscript out of bounds. This is a common thing when you're trying to use a loop and you end up out of bounds or something, okay? If you give back a list with null, you get back an empty list. And here, if you do list with double square bracket null, you get back an error message. Okay, so it's not that one of these is more preferable or less preferable than another, but it is helpful to know when you're going to get something, right? And sometimes you want to get the error message. Sometimes you want it to keep running. I don't know. Okay. Let's talk about matrices and arrays, and I need to pick up the pace. Okay. I think you're familiar with subsetting matrices. You use like a comma to say, I want these rows or these columns, but you can also subset them other ways. So here's a matrix. I've got rows 1, 2, 3, and columns A, B, C. And you can say, you can use a comma, and you say, I want rows 1 and 2, and I want all of the columns. Okay, and you get the first 2 rows. Here I've got the vector TFT, and again, T will alias to all caps true. All right, and so here I've got true, false, true, and so I'm going to get the first and the third rows. And here I'm asking for the columns B and A, and so I get the first and third rows and the columns B and A. Here I say I want none of the rows, and I want to drop the second column. And so this this is a matrix with no rows, and all but the second column, and only because it's named, so there's actually no elements being returned here, but it returns like, oh, okay, well, I guess we would have 2 columns, A and C here. If you subset a matrix, by default, it's going to simplify the structure of the matrix, right? So if you ask, hey, is this matrix a vector? It's not. It's got 2 dimensions. It's a 3 by 3 matrix. But if you say, I just want the first row, by default, it's going to simplify it. And it's not going to give you, and this is unique to R. I don't know about unique to R, but it's something that R does versus like Python doesn't do this, is that when you say, just give me the first row, it doesn't give you back a matrix that is 1 row and 3 columns. It gives you back the elements in that first row, and it simplifies it to a vector. right? So this is a vector with the elements 1, 4, 7. It is not a 1 by 3 matrix, okay? So single square bracket, 1 comma is the first row, but it's a vector and it's not a 1 by 3 matrix. So when you ask, is it a vector? It is a vector. Another thing we can do is if I create a matrix with the letters A through Y, sorry, letter Z, we can also subset using just using just a single numeric vector. So here I'm saying give me the 8th and 9th value. Okay, give me the 8th and 9th value. Here we're going to basically treat this as if it were a vector of length 25, and we're going to count down 1, 2, 3, 4, 5, and then F is 6, G is 7, the 8th is H, and the 9th is I, and so we get H and I. Okay, for Hi or Hawaii, and we can do that. Another thing you can do is you can subset a matrix with coordinates, okay? So imagine, so here's our matrix, 5 by 5, and you can say, I want the element in the first row, 5th column. That's what I'm having here. I want the element in the 3rd row, 1st column, 2nd row, 3rd column, 1st row, 1st column, okay? So 1st row, 5th column will be a U, 3rd row, 1st column will be C, 2nd row, 3rd column is L, and so you can pull out individual elements from this 5 by 5 matrix by kind of specifying coordinates, okay? And if you have a higher dimensional array, like a 3 by 3 thing, you can give it 3 coordinates. You know, I want this row and this column and this layer of the array, and something like that, right? So here I've got, so you can subset a matrix with a matrix, which is a little bit of a strange idea, but it is possible. Same thing with subsetting a 3-dimensional array, and I think I mentioned that, and we'll just go ahead and skip that. Okay. Data frames, we can subset data frames. Data frames are arranged like a matrix, but internally they are stored like a list. So you could subset them the way you would subset a list. You can subset them the way you would subset a matrix. So here is a data frame with 3 columns, X, Y, and Z. And here I am subsetting this using, with a comma, the way I would subset a matrix. So I'm saying give me back the rows where this logical statement is true. So I'm saying take column Y, mod 2 equals 0. Basically, I'm saying when is column Y even? Okay, so modular division equal to 0 means it divides evenly by 2. And so it's going to be true for the first and true for the 3rd row, but false for the 2nd and 4th row. And so when I say give me back those rows and I have a space after the comma or nothing after the comma, it's going to give me back all the columns. So I get the 1st and 3rd row where this statement is true. Let me give you your 3rd view quiz answer for today. 3rd view quiz answer is the letter E. E as in elephant is your 3rd view quiz answer for today. E. Here, I am subsetting a data frame the way I would subset a list. There's no comma before or after this vector. So what am I doing? I'm saying, okay, give me back the named elements of the list, X and Z. And so remember, a data frame is stored as a list where basically each column is like one of the train cars. Okay? So I'm basically saying, give me back train car X and train car Z. Train car X and train car Z correspond to columns X and column Z. And so I get basically a data frame with columns X and Z. Here, similar kind of idea. I have a space and a comma, and so I'm saying give me back all the rows, but the columns X and Z. And so these two result in the same thing, but this one's subsetting like a list, and this one's subsetting like a matrix. Okay. Here, I'm saying just give me the 1st and 3rd rows. Okay, comma. We do that. Okay. Now, if I leave off the comma, this is saying give me back the 1st and 3rd train cars, because now it's treating like a list, right? So 1, 3, comma, right? So the vector 1, 3, and then followed by comma says, treat this like a matrix, give me back the 1st and 3rd rows. If I leave off the comma, saying treat this like a list, give me the first and third elements in the list, which will be train cars, right? So these are very different. One thing is that if you give it a single character and you say data frame single square bracket X, you get back a data frame. If you do data frame comma X, this will simplify to a vector. Okay, so that is one kind of difference that you have to be aware of. That happens with data frames. If you're working with tibbles, which we will come across later, okay, not part of base R, but part of the tidyverse, and I do love the tidyverse, then single square brackets always return a tibble, whether you select one column or not. But in base R, this is a distinction. So that's what we have. If you do the $sign, it simplifies, and if you do double square bracket, it simplifies to the vectors. We know this, right? It's actually not simplifying; it's just extracting. It's extracting that vector. Okay. Simplifying versus preserving is a kind idea of like, do we simplify to a vector or do we kind of preserve its matrix structure type of thing? Also applies to atomic vectors. So single square bracket preserves the names, double square brackets drops the names. With lists, single square bracket preserves the list structure, double square bracket, you can think of it as simplifying or extracting that element. For factors, okay, single square bracket, if one thing, when you use a single square bracket, it preserves elements or levels that don't exist in the resulting factors. So here the original factor had A and B, and so it says levels A and B. And then if you say, hey, I just want the first element, it's going to be A, and the factor still contains the levels A and B. Whereas if you include, after you subset, you include the option drop equals true, it will drop any levels that don't exist in the resulting factor. So here it drops the level B. Okay, this is, I would say this is probably where the simplifying versus preserving is most, the key difference is most stark, is by default, when you subset a matrix and you say, hey, I only want the first row, okay, by default, it's going to simplify to a vector containing that element, those elements, right? So here I have, A is a matrix 1, 2, 3, 4, okay? 2 by 2 matrix, 1, 2, 3, 4. And if I say, hey, I just want the first row, it's going to return that first row 1 and 3 and simplify it to a vector of length 2, containing the elements 1, 3. If you want to preserve the matrix structure and say, I want a matrix with 1 row and 2 columns containing the elements 1 and 3, you can do that. You subset square bracket 1, comma, nothing, okay, which is what we have here. And then you put in another comma, right? And then you specify drop equals false. So this is like additional options after kind of this thing. So you're saying 1 commas, nothing, comma, drop equals false. Drop equals false basically means don't drop the dimensionality of this thing and keep it in this matrix structure, 1 row, 2 columns. Okay. Data frame, single square bracket preserves the data frame structure, double square bracket extracts that thing, so it's just a vector. All right, here's a couple examples, and I think we're going to run out of time, so you're going to have to just look at these examples on your own. But here's a data frame, and I said, hey, what went wrong when I said, hey, I want this. Basically, from here, one of the columns is the number of cylinders. So these are like different vehicles. How many cylinders does this vehicle have in its engine? And I'm saying I want all the vehicles where the number of cylinders is less than or equal to 5. And I get this error that says undefined column selected. So what went wrong here? What went wrong is I left off the comma, okay? So you need to have a comma to say I want the rows corresponding to this. Otherwise, it treats it like subsetting a list, and you're basically selecting the columns. And And so if you put in that comma there, then you will get the rows where cylinders is less than or equal to 5, and you get this, okay? And you have a few more of these kind of like what went wrong with here and here, and something like this. Basically what happened here, I said I want where the cylinders is 4 or 6, but it's selecting rows where the cylinders, I'm getting 8 cylinders, right? So it's not 4 or 6, but it's like I'm getting all of these rows. So what went wrong, right? Okay, well, you'll have to answer these on your own, in your own time as you go over these notes. Okay, have a great weekend. We will see you, Monday is a holiday, so we won't see you Monday. We will see you on Wednesday. So have a great weekend and see you Wednesday.